this is the paper from Cambridge IGCSE, Alternative to Practical, and 0620 May June 2022. We discussed question 1 in our previous video, and now straightforward jumping towards question 2 of the same paper. Here he says we are going to investigate the reaction between different solution of aqueous sodium carbonate, which is solution K and solution L, with the dilute hydrochloric acid. Okay, so now he is taking in the measuring cylinder 25 centimeter cube of K and then titrating it with the hydrochloric acid, which is in the burette. Just read these instructions, and I'm jumping directly to the table, completion of this table. He says that burette reading at first color change. So this is the burette reading at first color change. So it could be this 11. So exactly 12. It is exactly 12. So 12.00. As I clearly mentioned earlier, you have to note down the burette reading till 2 decimal places. Okay, till 2 decimal places. Next, this is the burette final burette reading at the second color change. So this is the second color change, and the reading is 22.1, 2, 3, and 4. So this is 22.40. The initial burette reading is 1.5 and then 6. So it is 1.60. To find out the difference, it says volume of the dilute hydrochloric acid for the first color change. So this was the first color change, so we have to find the difference of these two. This is 12.00 was the final and 1.60 was the initial. So the difference is we got 0 here, 4 here, and then we have 11. Now we have 10. 10.40. Okay, so 10.40. The total volume of the dilute hydrochloric acid for the second color change. So again, the final reading was 22.40, but the initial was 1.60. So we got 0, and then we got 8 here, and then we got 0 and 2. 20.80. 20.80. Got it? So we have to note these readings because these will be helpful in our next or any other situation. So we must have to note down 12.00, 22.40, 1.60, 10.40, and 20.80. Keep the record of these readings. Okay. And now we are going to proceed. He says that we did the same experiment, repeated the same experiment, but now using solution L instead of solution K. Okay, so what happened then? How much volume of sulfuric hydrochloric acid we used in this experiment? So this is what we were reading for the first color change. So this is the first color change, 19.5, 6, and then 7. 19.7. 19.70. We were reading for the second color change here 35.12 and then 3. 35.30. The initial was 4.1. The initial was 4.10. Now we have to find the difference. For the first one, the difference is 19.70 and 4.10. We got 0, 6, and then 5, 1. 15.60. And in the next one, total volume of the hydrochloric acid added for the second color change. So we have to find the difference again. The final was 35.30. Initial was 4.10. So the difference we got 0 here, 2 here, and then 1 and 3. 31.20. If you compare the readings here, I'm writing. So comparison independently here, it is experiment 1, and this is experiment 2. Okay, experiment 1 1, experiment 2. So what we can see here, it is 19.70, 35.30, 4.10, 15.60, and 31.20. So you can see the volume we used first for the first color change. For the first color change, it is 10 here but 12, 15 here. So we are using more volume of the hydrofluoric acid in the second experiment. And you can easily see more volume of the hydrochloric acid in the first experiment, in the second experiment as well. So what conclusion we can draw? We're not going jumping into the questions, but if you roughly make an idea, mean here volume of the acid used was less, so the concentration of the sodium carbonate used here was less. So that's why less volume of the acid was used to completely use it up or complete the reaction. But here we use more volume, mean here the concentration of the sodium carbonate was more. Understood? So keep that idea. Examiner may ask you some other questions. So we are going and jumping. Here he says, state the color change observed at the end point when dilute hydrochloric acid is added to the methyl orange. Remember, initially in the burette or in the beaker or in conical flask, what we have? We have sodium carbonate. Sodium carbonate. And sodium carbonate is a base. Sodium carbonate is what? A base. So when we add methyl orange into the base, when we add what? Methyl orange, which is an indicator, into a base, the color is always yellow. The color is always yellow. Okay? So the initial color must be, we can say, yellow. When the neutralization takes place, so the color will appear as an acidic color. So this will be orange or red. You may write orange, or even you can write red, but please write only one color, not the two. Yellow for alkali always, but for acid it should be or it could be orange or red. Then he says for experiment 1, compare the volume, like I compared earlier. He says compare the volume of hydrochloric acid needed for the first color change with the volume of hydrochloric acid for the second color change. Okay, so for experiment 1, we can say more volume, like in the first color change we need only 10, but for the second color change we need 20. We need 20. So simply you have to say more volume used. Okay? And then he also mentioned just compare with the volume of hydrochloric acid. Then he says compare the concentration of solution K used in experiment 1 to the concentration of solution L used in experiment 2 and explain. So as I said, concentration of K or concentration of solution L is higher than solution K, as more volume of acid used in experiment 2, or any other similar word that give you the idea that more volume was used, that indicate that the concentration of the alkali was more in experiment 2. Then he says deduce the volume of dilute hydrochloric acid needed for the second color change when experiment 2 is repeated using 50 centimeter cube. Using 50 centimeter cube. Now you have to make the ratio. Initially we were using 25. You can confirm it from the instructions which we skipped. How much volume we used? We were using, you can see, 25. Here you can see the volume of the K was 25, and then we repeated the same experiment. So that's why the volume of the L or K initially was 25, but and now examiner is indicating instead of the 25, we have to use what 50 centimeter cube. So we have to make a ratio. Okay, when we used 25 as compared, so L was used in experiment 2. So in experiment 2, you can easily see from here how much volume was used for the second color chain is 31.20. When we use this 25, the total volume was 31.20. So if in this case, if we use 50, what should be the volume? So it will be the double. Okay, so you have to make cross multiplication. Then x will be equals to 50 times 31.20 divided by 25. You can see 25 times 1, 2. So just multiply it and double, take it as a double. So it will be 2, 4, 2, 6, 62.42. So it will be 62.42 centimeter cube of the volume should be used. Okay. Then state why using 50 centimeter cube of solution would cause a problem. Would cause a problem. So problem is that the capacity overall or the total capacity of the burette is fixed 50. So where you start? Okay, sorry. So calculation was little wrong. Instead of this, we have to take 0. Okay, so 62.40 instead of 62.42. Just multiplication error. Okay, so you have to multiply using your calculator. Sometimes your math, mind math may cause some problems. So state why using 50 centimeter cube of solution L would cause problem. As I was discussing, this is the total capacity of the burette. So the capacity of the total or the total capacity of the burette is 50. So that may cause problem. We may not may use full problem. So we can say capacity of burette is 50 centimeter cube or 50.0 centimeter cube. So that may cause confuse us. So that's why this should be or this may be the problem. Then he says, furthermore, state advantage of using a pipette instead of the measuring cylinder. So it will be more accurate. Whenever we use burette or pipette instead of the measuring cylinder, it will be more accurate. More accuracy or accurate. Next, explain why the conical flask was filled as the dilute hydrochloric acid was added from the burette, so that the reaction may not, the carbon dioxide from the air may not get into the solution. Okay, so it may not make it more acidified. So that's why we have to take the proper color change. So here you have to give the idea swirling, making all of the particles from the acid to properly mix up. Okay, so acid may properly react with the base, and we can see a uniform indicator color, and or short version we can say to see uniform indicator color. Next it says at the start of experiment 1, the burette was rinsed with water and then with dilute hydrochloric acid. At the start of experiment 2, the conical flask was rinsed with water but not with the solution L. Okay, so because in that case, when we wash the conical flask with solution L, so some of the solution L may stay inside the conical flask. That may cause the problem and that may cause some other errors because of the volume already inside. Okay, so we are not going to swirl with the what L with the conical flask. So he say explain why the conical flask was rinsed with water so that we remove all of the solution K from the flask, so that we can remove all of the solution K or make it purified or just purified. And in the last part he says explain why the conical flask was not rinsed with solution L in experiment 2. Clearly, it may not then contain some of the part of solution L already. So, major problem. Understood? So question 2 is completed here, and we will continue inshallah for the question 3 in our next video.